Hello there and welcome to A2 Maths June 2018 paper 1, and here we're looking at the final question of the paper, question 14. So a curve C has parametric equations x equals 3 plus 2 sine t, y equals 4 plus 2 cos 2t, where t is in between 0 to 2 pi, show that all the points on the curve C satisfy this equation here. So this is C, but this is an equation where part of this curve is going to be on this graph here. So what we need to do is somehow link x and y together. I'm going to start with y, because y is equal to 4 plus 2 cos 2t. Now what I can do is I can expand this double angle formula here. I would probably like it to be the sine version of cos 2t, and if you remember, there are three different versions that we can turn cos 2t into, and I'm going to turn it into this one here, 1 minus 2 sine squared t. So after doing that, let's expand the brackets. 4 plus 2 minus 4 sine squared t. And now what I can do is I can now put sine into this expression here. Let's just simplify a little bit more. 6 minus 4 sine squared t. So looking at this, x equals 3 plus 2 sine t, what I could effectively do is I could write this as 6 minus brackets 2 sine t all squared. So all I need to now do is take away the 3 onto the other side of this expression up here for the x, and I get 6 minus x minus 3. That will give me 2 sine t, so I now just need to square it. So there we are. That's proven that this set of equations here can be transformed into this set of equations there. Or that's the Cartesian equation there. Sketch the curve for C. And I will jump onto part 2 as well, just to see how this is going to work. Explain briefly why C does not include all of the points on this curve here. So it's not the full 6 minus x minus 3 squared graph. We have to use this domain for t in here. So between t equals 0 and t equals 2 pi, the minimum that sine can be, let's just get rid of all this writing all over it. The minimum that sine can be is minus 1. So the minimum that x can be is 1. So this is the minimum value of x, because sine will go down to minus 1 at a minimum point. So therefore 3 minus 2 is 1. So the minimum x coordinate is 1, and the maximum x coordinate will be at the same point at which sine is at its maximum, at 1. So it's 2 times 1 is 2, plus 3 gives us 5. This is the maximum value of x. So in fact the curve is just going to be from x equals 1, let's work out what the y coordinate is going to be. 1 minus 3 is minus 2, minus 2 squared is 4, 6 minus 4 is 2, so it's going to be at the coordinate 1, 2. We're going to have a maximum point using the knowledge that it's going to be at a turning point at 3, 6, and then it's going to be a quadratic down to 5. And by the symmetry of any quadratic curve, it must go down to 5, 2. So therefore the curve is going to look perfectly like this thing here. A perfect quadratic, but stopping at 1, 2 and 5, 2, going at a maximum point of 3, 6. So there we are. That's the answer to the sketch for the graph, and explain why C does not include all the points, because the sine function is bounded. Okay, so there we are. Moving on to the last part now. I'm just going to redraw the graph that we had earlier, because we definitely need to work with it. So it's this thing here, 5, 2, 3, 6, 1, 2. So the line with the equation y plus x equals, x plus y equals k. Now the y plus x graph looks like that. It has a negative gradient of 1, so it's going to come down and it's going to look like that. Where k is a constant and intersects c at both the points, at 2 points. So we want it to intersect at 2 distinct points. So it might come down and it might intersect like that, for example. States the range of the values for k. So we've got one equation which is y equals 6 minus x minus 3 squared, and we have a second equation which is x plus y equals k. Now what we're going to look to do, the bit of maths that we're going to use to combine these two things, is the fact that the discriminant, if it intersects at 2 points, must be larger than 0. So what I'll do then is I will rearrange this second equation here to k minus x and replace it for y in the first equation. So it's going to be k minus x equals 6 minus, and now I'm going to expand the brackets on the right hand side here, x squared plus 6x minus 9. Pretty sure that's what it will equal. Let's now move everything onto the left hand side, so it's going to be x squared plus 6x on, so take away 6x onto the other side, so I'm left with minus 7x on the other side, and then add 9 onto the other side. We've got this take away 6 as we've got take away 6 on the other side as well, so that's going to leave us with plus 3 plus k on the other side. Okay, so now is when I need to use my discriminant facts. So this value here, a is 1 in this quadratic, b is minus 7 in this quadratic, and c, well, c is k plus 3 in this quadratic. So b squared minus 4ac time. b is minus 7, so that's going to be 49 when we square it. Take away 4, lots of 1, that's a, lot times c, which is k plus 3, and we need this to be bigger than 0. Right, okay, let's now expand the brackets. 49 minus 4k minus 12 needs to be greater than 0. So now putting the 4k on the other side and combining these two together, that's going to make 37. So now we need to do 37 divided by 4 is our biggest value for k. K has to be less than 37 over 4. Effectively, 37 will be the point at which it kind of just touches, or just beneath it just touches. Right, so there we are. But in this case here, it's not going to be quite that simple, because by the time we've got to this point here, it's going to go down and only intersect it at one point. So we also need to work out the point at it will intersect this point 5, 2, because that would be the last time that it can intersect at 2 points. So we've got the coordinates of 5, 2, and we've got the equation x plus y equals k, so therefore we can plug these x and y coordinates in. 5 plus 2 equals 7, which is our value for k. That's effectively kind of like our smallest value that k can be. It can be anywhere, so our final answer is anywhere in between 7. It could equal 7, but it can't be anything more than 37 over 4. Okay, so there we are. That's the final answer to this problem here. K has to be bounded in between 7 and 37 over 4. So there we are. That's the answer for 5 marks there, finish showing off question C. So that's 10 marks in total for question 14. Let's now move on to paper 2.